Right, the next bit is about static electricity and how we actually create static electricity. So this is one of the uses of static electricity that's shown here in the diagram. You can see here. And this is actually someone who is painting a car using what we call an electrostatic paint spray. So we'll explain that in a second. Right, first of all, how are objects charged? So objects are charged whenever you rub two things together. So what do you call the force you get when two materials rub together? And hopefully you were saying the word friction. Now we know that friction causes heat. And when that heat energy is given to the atoms in something like a plastic or whatever, it can cause electrons to move. But those electrons aren't forming a current as such. Those electrons can move from one particular material to another material. So let's say you rub an insulator with a cloth. Two things can happen. Electrons can move from the cloth to the insulator, or they can move from the insulator to the cloth. And those have two slightly different effects. So I'll just show you a picture here. This is a piece of plastic that the person has in their hand, and this is a cloth. Now before rubbing, both of these are neutral. The charges haven't been shown in the strip because the strip's too small there to show that properly. But you can see all these positive and negative charges, and if we counted them all up, we're not going to bother today, but if we counted them all up, you would actually see that there are equal numbers of positive and negative charges, and this cloth is neutral, and so is the strip. So before any static charge happens, the cloth is neutral, and so is the strip. If, however, you rub the cloth, or rub the strip, then one of two things may happen. Now, this first slide is just suggesting that electrons move from the insulator to the cloth. So if the electrons move from here, so if we've got negative electrons moving onto the cloth, that means that the cloth ends up with an overall negative charge. It still has all the positive and negative charges it had before, but it now has got extra negative charges, and so overall it's negatively charged. The insulator, however, it had equal numbers of positive and negative charges, but some of the negative charges have now moved onto the cloth. So overall it has more positive left than negative, and it is positively charged. Now it's very, very important you realise, given that I showed you the structure of an atom, it's only the electrons that are able to move. And it's only electrons that are able to move because the protons, or the positive charges, are held so tightly in the nucleus. It would take a nuclear reaction to move the protons in the nucleus. And that's not going to happen if you're just rubbing a piece of material with a cloth. So it's only the electrons on the outside that, given a little bit of heat energy from friction, they're allowed to move, and they move quite freely from one insulating material to another. If it happens the other way around, if you have got your cloth and it loses electrons onto a piece of plastic, then the piece of plastic becomes negatively charged. And since the cloth has lost electrons onto the strip, then it ends up positively charged. So the cloth is positively charged, and the insulator or the strip is now negative because it has gained electrons and the cloth has lost them. Again, it's only electrons that are free to move. And when you explain this, you must explain that it's only electrons. You never talk about the positive charge moving from one material to another. It's always electrons. So the electrons either move off the strip onto the cloth or move off the cloth onto the strip. Which way they move depends on the nature of the cloth and the strip. It depends on which one is more likely to lose electrons. Okay. Now, attraction and repulsion. So you know this already, especially from magnets. You already know that if you have like types of, in this case, charge, like types of charge, like positive and positive, repel each other. So there's negative and negative as well. Now you mightn't be able to tell from looking at them that they're both positive or they're both negative, but you'll know when they repel that they must be both of the same kind of charge. And then positive and negative charge, which are unlike charges, they attract. So just to finish this off, like charges repel and unlike charges attract. If you don't know the type of charge, but you have another charged object which you do know the kind of charge, if you bring a positively charged rod near another rod and then they are attracted, then the unknown rod has to be negative. It must be negative because, as you know, unlike charges attract. If, however, you bring it near a positively charged rod, and it repels this time, so I'm just going to change that into a plus, and it's going to repel away, then the unknown charge must be positive, because you know that like charges repel. So the opposite, of course, is true. For if the rod is a negative rod and you bring this unknown charge up, then if it is negatively charged, then it's going to repel, and if it is positively charged, it's going to attract. Now the last little bit about charges and why some things attract and so on is sometimes you can get a charged object and a charged insulator, and that insulator might attract a completely uncharged object. Now you generate something very light like dust particles or little tiny pieces of paper, or it might be your hair, something that's generally very light. So if you bring up something which is charged, the paper's no charge, you can see an equal number of positive and negative charges there in this uncharged piece of paper. So it's neutral at the minute. Then the negative charge has an effect on the paper that it repels any negative charges close to the edge. And so these electrons move to this side, and that leaves this overall side positively charged and this overall side negatively charged. And then you know that negative and positive charges attract. And so the little pieces of paper are attracted to the insulating material. This is just like your hair being combed with a comb. The comb will become positively or negatively charged, and it will attract the hair. And the last bit in this section, inducing a temporary charge. This time, if you have a positively charged object and you bring it up to your neutral piece of paper, remember it's very, very important you explain that it's the negative charges that move. So it's very tempting to say, oh, the positive charges are repelled. They're not. The positive charges can't move. And so it is the electrons which are attracted over to this edge, which leaves it overall with a negative charge, and negative and positive attract.